I'm looking at the region which is bounded by the y-axis, the cos x and sine x. So I've already have the y-axis. I now need to just draw the cos x and the sine x. So I've drawn, to the best of my ability, the sine x and the cos x. The cos x is in blue and goes down here, and the sine x is in red. The region that's bounded is just a tiny bit here between the y-axis and where they meet together. And I've highlighted it yellow here. So using the formula for the area, we will write the integral of the lower boundary to the upper boundary of the y, the function which is upper, take away the function which is the lower. And by drawing these functions, we were able to establish that the upper function is going to be the blue cos function, and the lower function is going to be the cos sine x function. And we know that the lower boundary is 0 because it's the y-axis, so we'll say lower boundary 0, but we need to find out what the upper boundary is. And the upper boundary only will happen when we've got cos x is going to be equal to the sine x. Now I want to define to you complementary. The cosine of an angle is defined as the sine of the complementary angle. And complementary means that the sum of the angles must equal to 90 degrees. So I want you to look at the two words, cosine and sine. Cosine and the word sine. Can you see that this cosine has got a co in front of it, the sine. That means the complementary of sine. And this is where we get the two words, cos and sine. For example, cos 30 is equal to sine 60, as is cos 60 will be equal to sine 30. Cos 25 therefore will be equal to sine 65, and cos 45 will therefore be equal to sine 45. And these are all angles in degrees. So now I want to talk about the radians. So imagine the unit circle where this is going to be pi on 2 and this is 0. If I was to draw another angle here, which would be pi on 4, you can see that pi on 4 cos and pi on 4 sine are going to be the same. So we can write that cos pi on 2 is equal to sine 0, and cos 0 is equal to sine pi on 2. Also we can write that cos pi on 4 is equal to sine pi on 4. So if we look up over here, we know that the boundary here, a second boundary, will be pi on 4, just as this is pi on 2 and this is pi. Another way of establishing this was by saying that sine x is equal to cos x. We can rearrange this and say sine x over cos x is equal to 1. And we know that sine x over cos x is really a tan x, which is equal to 1. So the x therefore is equal to 10 to the negative 1 of 1. And that you'll find out using the calculator as being 0.7853, which is the same thing as pi on 4. Now we can work out the area by integrating from 0 to pi on 4 of cos x minus sine x dx, which is equal to sine x plus cos x from 0 to pi on 4. And if we substitute that, becomes sine pi on 4 plus cos pi on 4. And now we're going to subtract this sine 0 plus cos 0. Now, sine pi on 4 is 1 on root 2 plus cos pi on 4 is also 1 on root 2 minus 0 plus 1. So once we work it out, we'll have 2 over root 2 take away 1. Sometimes you'll see that this is written as root 2 take away 1. And the reason for that is because if I look at 2 root 2, I can change that into 2 root 2 on root 2, the same thing, because root 2 times root 2 is 2. Cancelling these two out, I'm left with root 2, which is how I got root 2 over here, and that is the answer.